Are there any irreducibly complex biochemical systems, cells or systems in the cell? Yes, it turns out the cell is loaded with such things. And an example of one is shown here. Here's an electron micrograph of some lung tissue, and lining the lungs are cells that have all these little hair-like organelles sticking out of them. They're called cilia. And the cilia beat in synchrony like this, like the oars of a Roman galley. When you get dust particles or whatever in your lungs, this is a mechanism to clear your lungs out. Now, these cilia look pretty simple, but we should be suspicious. Why do they beat like this? The hairs on my head don't beat like that. It would be entertaining if they did, but they don't. How does that work? How does the psyllium do that? Well, it turns out that biochemical investigations over the past quarter century or so have shown that the psyllium is a very complex molecular machine. And here's, on the bottom part of this transparency, is shown a cross-section through one of the cilia. And as you can see, it's pretty complex. It consists of 9 what are called double microtubules. And each one of these double microtubules, one of the rings consists of 13 different strands of a protein called tubulin, and the other one consists of 10 strands of the protein called tubulin. They're connected to each other by a number of links. There's a small link here called nexin, and here's a radial spoke linking the double microtubules into the central single microtubules, and the central single microtubules are connected to each other by a connecting bridge. Additionally, attached to the microtubules are a couple of arms. This is called the outer dynein arm and the inner dynein arm. And even though this looks complex, it really doesn't convey the full complexity of the psyllium. Biochemical investigation shows that a typical psyllium consists of over 200 different kinds of protein parts. Well, that's what it looks like, but how does it work? Now, perhaps you can see that the psyllium is irreducibly complex. If it were not for the microtubule sliding fibers, there would be nothing to generate the motion, nothing to beat. If it were not for the nexin, when the dynein started to push them apart, they would just fall apart, as happens in experiments when the nexin linkers are removed. If it were not for the dynein motor proteins, the apparatus would lie stiff and motionless, kind of like in rigor mortis. So again, a psyllium, an irreducibly complex structure, is a big challenge for Darwinian evolution because one does not get the function of the psyllium until the ciliary components are in place. Let's look at another example of irreducible complexity. And this is kind of like the first one, but significantly different. And it's called a bacterial flagellum. The bacterial flagellum is literally an outboard motor that bacteria use to swim through solution. It's a rotary device. And this is the propeller surface, and it rotates. And it's held onto the drive shaft here by this universal joint made up of something called hook protein. And the apparatus is held in place in the bacterial membrane by this stator. And the motor this is a rotary motor, which is the rotating part, which turns the drive shaft, which turns the propeller. And it has to go through the bacterial membrane, so there are a number of different bushing proteins to allow it to penetrate the membrane. Genetic studies have shown that over 50 different separate protein parts are required to produce a flagellum. About 20 go into making up the structure of the flagellum, and another 30 are needed to coordinate the genes to turn on and off at the right time in order to build this massive structure within the bacterium. The flagellum is irreducibly complex too. If it's not for the propeller, you would not get any motion when it rotated. If it's not for the stator, the device would rotate in the membrane itself. And of course, not for the motor or the bushing proteins, the device would not work either. In the absence of any of those 50 different components, you do not get a flagellum that works half as well or a quarter as well again. You have a broken flagellum. I'd just like to point out that I like to use this illustration, which is from a popular biochemistry textbook written by Voet and Voet, because when people look at this, they can immediately see that this is a machine. It's not like a machine. It is a machine. Now, there are many other examples of such systems which have this property of irreducible complexity and which are subsequently a strong challenge to Darwinian gradualism. The way that Darwin thought his theory would have to work. But, you know, I did not work out the structure of these things. I didn't do it in my laboratory. This was work done by many, many different laboratories, working hard over several decades. If these things can't be explained by Darwin's theory, as I propose, what have other scientists had to say about how these things could be put together? I'm glad you asked. A good place to look for an answer to that question is in a place called the Journal of Molecular Evolution. Now, as its name implies, this is a scientific journal that was set up specifically to investigate the question of how life might have been produced at the molecular level. In the past 10 years, the Journal of Molecular Evolution has published about 1,000 papers. Of those 1,000, about 800 are sequence analyses. About 100 have to do with studies of chemicals thought to be necessary for the origin of life. And about 50 are mathematical studies to improve sequence analysis. Of those 1,000 papers, how many propose models whereby for the gradual evolution of complex biochemical structures such as we talked about? It's a round number. There weren't any. There are none. Zero. Zip. It's not what you would expect from a journal with the name Journal of Molecular Evolution. If you look in other journals, Journal of Molecular Biology, Proceedings National Academy of Sciences, the story is pretty much the same. Sequence analysis predominate, but there are extremely few, if any, studies on how complex biochemical structures might have been put together. Well, if that's the case, why do scientists believe in Darwinian evolution? Well, I don't know. I don't. But at least one part of the answer is that they're taught to believe that. And many textbooks, of course, teach biology from the Darwinian perspective, and they seek to imbue in their students the ability to see the world through a Darwinian lens.